For this example, we want to describe the local and end behavior of the polynomial p of x is x plus 1 times x minus 2 quantity cubed, and then we want to sketch the graph. Think about local behavior first. So for local behavior, we're basically looking at zeros and the behavior near zeros. So because this is already factored, we know that p of minus 1 is 0, and that p of 2 is 0, and these are only two zeros for this polynomial. So to see what happens nearby, we can also do a sign chart, where we mark out minus 1 and 2. Now if I plug in 0, I see here that I will get 0 plus 1 is 1, times 0 minus 2 is negative 2 cubed is negative 8. That's a negative value in here. If I plug in minus 2, I'll get negative times negative, so that's going to be positive, and it's going to be positive over here. This also makes sense because negative 1 is a multiplicity 1 root, so the graph should pass through the axis at negative 1. And 2 is a root of multiplicity 3, which since it's odd, again, the graph should pass through the axis. So the fact that it goes plus to minus here and minus to plus here makes sense based on the situation. Now, end behavior. If you look at this polynomial, we see that it's degree 4, because I have 1x here, and I have 3 x's here because of the third power. Therefore, this will be an x to the fourth, and the leading coefficient is 1, because when I multiply that, I'll get the x to the fourth in the first term, plus lower order terms. And this term here determines the end behavior. So since I have a positive coefficient and x to the fourth, which is an even power, we know that p of x goes to infinity as x goes to infinity, and it goes to infinity as x goes to minus infinity. It goes up both ways because it is a even power with a positive coefficient. Now we can sketch this graph. I know I want zeros at minus 1 and plus 2. And my behavior should look like to infinity on both ends. I know that my 0 at minus 1 is a linear function because it's the first power, so it should pass through it this way like it's linear. And for x equals 2, that's the third power, to look like x cubed near that point. So it should sort of come up and go up like this. And from those pieces, we can then sketch out our graph. So it comes in this way, goes through here, has a turning point somewhere down here, and then goes off that way. That's so we can take this information about local and end behavior of our polynomials and use it to sketch some graph of what it looks like. And if you look at a graph on Desmos for this function, you'll see that the graph is pretty close to this. The scale is a little bit off, but the idea is pretty accurate and the right shape is all there for this function. That's how just from the function itself, from the polynomial itself, we can use the information we know about it and how it acts to draw a reasonable sketch of this function.